Hey guys, super excited to be back and starting off our first session. So in this session, we'll be watching or we'll be rather seeing what is blockchain. We'll be understanding the definition as well as we'll look into the history of blockchain. So before we dive into the essence of what is blockchain, we will first have to understand history of money, right? So what is money? I mean, a lot of people assume that they know what is money, but in reality, right? Money is just a sort of an exchange system, right? You exchange something and you get back something in terms of value as return, right? So there were different forms of money throughout history. Firstly, it started off with barter system. This was the first initial form of money. So in barter system, what used to happen is people used to exchange goods for goods, right? So if let's say if you had three bags of rice and if I had two chickens, you would give me those three bags of rice in exchange of those two chickens. So there was no common base currency, right, which was used. So for every people had their own form of currency. It only was dependent on what the value of that commodity is, right? So if there were different, they were basically different people from different traditions, from different backgrounds, and they had their own talents. Some people were good in agriculture. They used to grow rice. Some people were blacksmiths. Some people were I don't know, egg cultivators, etc. Right? So depending on people's need, people used to exchange these commodities based on their own talent and what they used to grow or produce. So after a while, after a few years, when I say few years, I probably mean couple of thousand of years. People started realizing that there has to be some standard for this currency so that they could exchange the same currency for different items. And that is when they actually started using cowrie shells, right? So cowrie shells was widely used for a long part of time, but then it was too obvious that people who used to stay beside the sea were more richer, right? So to avoid this kind of injustice, people slowly started moving into coins, right? Now, coins was a de facto standard for a long time because that was when kingdoms and rulers started coming into the picture. So these kingdoms used to mint their own coins and use that in the form of currency, right? So obviously, the first choice by preference was gold. So people used to mint gold coins. But then over time, there were a lot of disadvantages to moving gold coins around because one such a disadvantage would be to chip off the gold coins itself, right? So you can actually chip off a small piece of gold coin or a little bit of gold dust and then pass on that currency. And if you do this with every coin which you're going to get, then ultimately you're going to hold some amount of gold dust, which is value by itself, right? So coins again was not, I mean, it was a good system. We do use coins even now, but not in the form of precious metals, right? Then the coins started coming in the form of aluminum, in the form of copper, and even this lasted for a few thousand years. Then came the introduction of centralization. Okay, money started getting centralized, right? Obviously, it was in the form of kingdom treasury for some point of time, but then banks started coming over, financial institutions started coming over, and then they started introducing paper notes, right, or bills as we call them. So notes and bills were became standard because this was given by this centralized authority, right? It could be the banking centralized banking institution, like for example, how we have RBI for India, or it could also be, let's say, by one particular bank, by this particular federal bank, right? So paper notes became the de facto standard, and then it moved on to uh, credit cards. Credit cards became plastic money. Plastic money was and is also being used very commonly, where you have a card and a chip within it, which records the transactions and then sends it over to the bank, right? So after all of this, right now, right, as of 2023, we are in the middle of a digital revolution, right? Because now money has become digital as well as decentralized, right? Money is not being held with one person. as well as it has not been held or it's not been created by one particular source. So with this change or with this revolution, I would like to introduce you to Bitcoin, right? But again, before going into details of Bitcoin, we'll again have to see a little bit of the history of Bitcoin as well, right? So Bitcoin obviously came around somewhere in 2008. So we'll first understand what happened before 2008. So Bitcoin was not the first attempt at digital money. There were multiple attempts made in the past as well. The first reference, B Money, which was created by this person, Wei Dai. So he thought about decentralized currency, right, which was not possible to be controlled by governments and trusted entities. So he introduced this concept of B money, but that did not obviously go around for a long time. Then Scott Stornetta and Stuart Haver, these guys came up with a time-stamped based record keeping, right? So they basically ensured that every data which is being put into some sort of a database which these guys were having was time-stamped, right? So you're trying to give a seal of authority in terms of time because time is unique, right? Every second, right? This second happens only once, right? When I talk, if you break down that definition of that second or the data of that second into what date it is, which year it is, which minute it is, right? You'll realize that this is a unique value. And they actually came around with this concept, which was kind of it did have its own sense of success, but then it wasn't used in the currency space, right? Then in 1992, they bought a much more stronger data structure with the form of with something called as Merkle trees. Now, Merkle trees is a data structure which we will be discussing later. So ultimately, their goal was to keep records without any tampering being done, right? Without any modification being done to that particular data. So with all of these technologies existing before 2008, uh, Satoshi Nakamoto, who is the founder of Bitcoin, just borrowed these pieces from different areas and then combined together with this innovative blockchain technology. And he represented this in a white paper, right? Now, what is a white paper? White paper is anybody, if you have any idea, you can like put it into white paper with a specific format and then leave it out or publish it out to the internet for everybody to see. Right? Now, you could have multiple purposes to it. It could be to share your knowledge. It could be for investment, for funds, whatever. You can write a white paper and publish it. Right? So that's what Satoshi Nakamoto did. Now, who is Satoshi Nakamoto? That's a big question, which is unanswered even till date. Right from 2008 until today, we still don't know who Satoshi Nakamoto is. It was authored by this name, right? We don't know if Satoshi Nakamoto is a he, if it's a she, or if it's a government organization, or if it's a group of people. I mean, we have no clue who this person is. We just know that this white paper was authored with this particular name, right? So, Satoshi Nakamoto released this white paper. He explained how he would use decentralization and how he could use cryptographic proofs in order to create his own currency. Right? I mean, not it's not his own currency because again it's decentralized. We'll come back to what centralization and decentralization is. So he came about understanding various practices and combining them to create this form of money, right? So on 18th August 2008, there was registration of the domain name bitcoin.org. And on 31st October, this particular white paper was released. Now, you might be seeing this other person here in the slide, Hal Finney. So who is he? He was also a integral part of building Bitcoin. Now, this was immediately after Satoshi Nakamoto, right? Now, these guys were all remotely collaborating, right? And this was back pre-COVID era, right, where we did not have this concept much of working remotely, but it started out as an open source project, and then they became pretty close to each other virtually, right? So Hal Finney is the first receiver of Bitcoin. He played a huge role in orchestrating the entire product right from the white paper till completion, till the product was actually completed. So Hal Finney was something called as of a group called as a so Hal Finney was part of a group called as a cypherpunk. So cypherpunks were guys who are looking to liberate the world using technology and using cryptography. So Hal Finney was a very avid. So Hal Finney was very much interested in the concept of Bitcoin ever since he heard it online from Satoshi Nakamoto, and then he played a huge role in the development of this particular product. So now we come to the definition, I would say informal definition about what is blockchain. So blockchain is a decentralized database consisting of fixed length blocks, right? Again, what is decentralization? We'll be looking at it shortly in detail, but it consists of fixed length blocks. What is a block? It is just this hypothetical structure which talks about how data is being stored in it, right? So you would have pieces of data or sections of data called as blocks. What do these sections contain? Blocks in a blockchain include a number of transactions as data, right? If you see blockchain in a way, it is a database, right? There's a lot of people who compare it with blockchain versus database kind of a debate. So it is loosely termed as a database because it ultimately holds data. Now, what is this data? This data is a transaction. With respect to the Bitcoin blockchain, it could be a financial transaction. With respect to other blockchains, there could be other type of transactions as well, which we'll see in later part of the course. So the first block in the blockchain is called as the Genesis block. So as the name suggests, Genesis, which means birth or the initial part of anything. So Genesis block basically do not have transactions. They will only have metadata, right? So the block basically consists of two sections. You do have the header as well as the body. Now the header is consisting of metadata, and then you have the body of it, right? So the header part, uh, by the way, what is metadata? Data of data is called as metadata. You do have the structural data, but then there might be certain details which is important to define the actual data by itself. So if you see here in the slide, I have put up an image where we show the metadata of an image, right? So what is the image by itself? If you see an image, if you see a picture, if you take a picture with your phone and you see it, you see different pixels with different colors, right? That actually constitutes the entire image. But if you put that, or if you transfer that image in your laptop or in your desktop, whatever, and if you check the properties or check the info of that image, you will find something like this, right? You will see which camera was used, um, who is the maker of that particular camera, and then which lens was used, size, exposure, aperture, etc., right? Now all of this data will in one way it actually defines how beautiful that actual picture is, right? What was the different settings which was used in order to capture that particular picture. So the same way for every block you do have metadata, and then you do have a body as well, right? Body, it just consists of transactions. So this is a structure of a block. By the way, before I continue, we spoke about the white paper of Bitcoin blockchain, right? I would strongly suggest everybody to have a read of this white paper. You can just Google Bitcoin white paper, and then in the first link, you should be able to find it, right? Now, if you see, it's a very short white paper, just 9 pages. You can have a read, but if you are not a technically sound person, you may not understand it. If you have never heard of the term cryptography, there are high chances you may not understand it at all. But I still suggest you have a look at it. You just get a feel of this wonderful technology which Satoshi Nakamoto presented to the world, right? Anyways, getting back to the session, where were we? Yeah. So now we'll look into these terms, centralization and decentralization. Before understanding decentralization, it's important to understand centralization. Only then you can appreciate the differences between the two. So centralization, it is when you are reliable on one central source of information, right? Now, just to give you a practical example, let's say you log into um, I don't know, Instagram, right? Now, on Instagram, once you log into Instagram, I mean, you might be doing this through an app or through a website, whatever it is. Once you enter the application, you see that you see images, you see your feed, right? Now, from where does this feed arrive? It comes from the Instagram servers. So if you see here, Instagram server is responsible to send that information to different parties. I mean, it could be different devices, it could be different servers, it could be different people throughout the world, right? And it is not just a one-way movement of data, it could be a two-way movement as well, right? Somebody might want to upload an image, right? So you're just not using the servers to retrieve the image, you might also want to upload an image up to that particular server, right? So if you see here, the server itself or the Instagram system itself acts like a centralized system, right? You have different clients, different people who are trying to connect to this particular centralized system for XYZ reasons. So what are the advantages? One, it is definitely easy to maintain, right? I mean, you might question that why is it easy, but I mean, if you consider it with Instagram's example, it could be difficult. But if you are building your own application, if you are maintaining a database by yourself on your laptop and you're like supplying it to different applications, then it's comparatively much easier to maintain. It's easier to control. Obviously, if my laptop has a database, I can decide what I want to do with the database, how to modify the database, delete the database. I can do anything, right? It is also fast because you are talking just with one central point, and it is cheap or free in some cases, right? Like these days, you have different cloud providers. You have different services which gives you services. I'm sorry, which gives you storage for free. Now the disadvantage is it is less secure, right? As I mentioned, if I am a person who's having a database with critical information, I can choose to delete it at any point, right? So it is not secure, and it also has a single point of failure. What if I drop my laptop tomorrow? What if I don't know, there's some spillage, there's coffee spilled on my laptop, right? If you see, just because of one silly move or one particular wrong wrongdoing by anybody, as long as they're having custody of the data, they could in fact destroy the data or even worse, modify it to a very crazy extent. So what is the solution? Now we'll talk about decentralization, right? So what is the need for decentralization? So earlier data was being stored through three different generations, right? Earlier it was Gen 1, which was on-prem servers or on-premise servers, where we used to have a server room where these CPUs used to constantly be on and they used to actually hold data, right? Now, this was, I'm pretty sure you guys may not have seen it, but I have seen it in earlier part of my career where these server rooms were like these spooky places where there is constant grinding of CPU fans, right? So on-prem servers were the de facto standard earlier, but then Gen 2 came over and then people started using data silos, right? Again, on-prem servers have all the disadvantages what I mentioned in the previous slide. So people started looking at a different approach. So there was this data silos where data used to kept held, where data used to be held separately, right? So if I have an office and I have all my data with me, probably the office could catch fire, right? So what I should do is to keep the data in a different location, and I used to keep certain people who used to manage that particular servers and that particular data, right? Now, even this has a disadvantage because there's no guarantee of that place not catching fire, as well as there's no guarantee of somebody whom have given this authority to control this data may be a malicious person altogether, right? Then came the third generation, where right now we are also using something called as cloud service, right? Now, for cloud servers, uh, you see there is it's not a simple. So if you see cloud servers, you are reliable or you are dependent on some other person, some other service provider to give you that infrastructure. After all, cloud also are physical servers in some part of the world, and they're just giving you that service to use, right? So if you see, all of these are again in some or the other form, they are still revolving around centralization, right? Now, to avoid all of these single point of failure, we bring in something called as decentralization, right? As you're seeing in this image here, there are multiple people, okay, they may or may not know each other. These multiple people will take custody of the data, right? Now, why are you doing this? Because you don't have to trust one person, or you don't have to give that leverage to just one person. Now you have different people who are handling the data, and you can ask the data validation from these different sources, right? So what are the advantages? They are fault tolerant. Even if there is some failure or some fault, it can still be managed, or it can still be mitigated. It provides equal authority to all nodes in a network. If you're holding the same data with 10 people, then definitely it gives all 10 people equal authority. It eliminates the need for intermediaries, very similar to, let's say, cloud service providers, right? But then there is also disadvantages, right? There's the flip side of the coin is that it requires coordination between multiple parties, right? As I mentioned, they may or may not know each other. So how are you going to get 10 different strangers from throughout the world to agree upon something, right? Which we will see how Satoshi Nakamoto actually solved this particular problem. And secondly, it is slower, right? This is something which we all have to agree with, that it is not as fast as talking with a single point. Now you're talking with multiple points, and because of that, there might be some latency and there might be some slowness as well. So with this, we complete the first session. I hope you guys enjoyed this session. You guys can have watch the resources and also see different videos on the same topics, and then we'll catch up for the next time. Thank you so much.